Assalamu alaikum and very good morning to everyone. So today I will be presenting our study on the implementation of outcome-based education (OBE) in the Plant Control System course BGL 553 conducted at Politeknik Sultan Halim Shah. So this course is offered by the Mechanical Engineering Department, which in diploma in mechanical plant, and the research was carried out by me along with my colleague Mr. Ahmad Shafawi and also Mr. Nizam Osman. As an introduction for this presentation, outcome-based education (OBE) is a strong emphasis on achieving specific learning outcomes, making it highly relevant to technical and engineering education. So in the plant control system course, the students are taught essential concepts such as the fundamental of control system, block diagram representation, dynamic behavior analysis, and advanced control. So the course integrates theory with practical application to ensure students develop both technical and analytical skills that meet industry standards. Despite structured teaching that includes lectures, hands-on activities, and various assessments, challenges remain in ensuring students fully understand and can apply the concept of the course. So the complexity of technical content in DGL 553 make it difficult for some students to internalize the material effectively. So additionally, there is a gap between how students perceive their learning and their actual academic performance. So this highlights the need for evaluating. So this highlights the need for evaluating the alignments between intended learning outcome and real achievement, and for identifying ways to improve teaching strategies and course delivery. So this study has three main objectives. First, to evaluate how effectively outcome-based education has been implemented in the DGL 553 course. Second, analyze the alignment between student academic performance and their self-learning. And third, to identify areas for continuous improvement in teaching and assessment methods. In terms of scope, so the study focused on the DGL 553 course taught in semester 5, which covers control system fundamental, modeling techniques, and advanced controls. So we collected and analyzed data from course outcome review reports, exit survey, and various assessments, including quiz, project, and exams. So this comprehensive approach helped us assess learning effectiveness and guide continuous quality improvement. So this slide summarizes key findings from the literature that support our study. First, regarding OBE implementation, Alto Wajri and Board of Engineer of Malaysia emphasize the importance of focusing on measurable industrial relevant outcomes. So to achieve this course objective, teaching strategies and assessment methods must be well aligned with expected graduate skill. Next, on the subtopic of the student performance versus self-perceived learning. So Gonzalez and Jumhur highlight that student understanding should be evaluated through various tools such as tests, project, and exit surveys. So it is also critical to compare student perceived learning with their actual academic performance to ensure the course delivery is truly effective and aligned with learning outcomes. Now let's take a look at the key insights from the literature review, which are grouped into three major focus areas. First, under CQI, continuous quality improvements, the literature emphasized the importance of using student feedback and performance data to inform course updates. So studies like those by Roziah, Kyria, and Munawara highlight that lecturers are encouraged to adopt new tools and continuously update their teaching strategies. Second, in terms of technical knowledge and skill development, so these three course learning outcomes (CLO) are discussed, which CL1 covers the fundamental thought of tutorial and quizzes, CL2 focus on modeling and mini projects, and CLO3 incorporate AI tools to develop advanced control strategies. So these points are supported by Gonzalez and Zainuddin. Lastly, the literature supports integrating real-world application and sustainability into practical projects. So this approach not only encourages real-world problem solving and sustainability, but also enhances student critical and creative thinking. So this again is reinforced by Zainuddin. These focus areas form the backbones of effective and forward-thinking engineering education. So this slide outlines the methodology applied in the study, which consists of three main components. First, under data collection, we gathered data from two key sources, the course outcome review reports and the exit survey, covering 4 academic sessions. So these sources provided quantitative insight into students' learning experience and outcome. Second, in the performance and feedback analysis phase, we compare student actual academic results with their self-reported learning outcome. So this helps us understand how well student perception align with their academic performance. And finally, for CQI, continuous quality improvement, we identify areas for enhancement by analyzing trends and aligning them with teaching strategies and practical learning activities. So this step supports iterative updates for better learning impact. So this slide presents the results of the course learning outcome or CLO achievements for the DJL 553 courses across academic sessions. So from the bar chart, we can observe that CLO2 consistently achieved the highest performance across all sessions, with achievement percentage typically above 75%. So this suggests strong engagement in many projects and practical tasks which CLO2 emphasizes. So on the other hand, CLO1, which covers foundational knowledge through quiz tutorial, recorded the lowest achievement in most semesters, particularly in session 2 of 2022-2023, where it dropped below 50%. However, there is a positive upwards trend in session 1 of 2024-2025, with all three CLOs showing improved performance and CLO3 reaching 100% likely due to better integration of AI tools and practical content. So the pie chart shows the distribution of 47 student response collected over the 4 sessions. So a majority, about 59.6%, came from session 1, 2024-2025. So the remaining response were evenly distributed across the previous 3 semesters, which contributing around 70%. So this finding indicate not only an improvement in learning outcome over time, but also reflect the impact of continuous course refinement as aligned with CQI practice. So the results of the exit survey for the DGL 553 course reveal a detailed distribution of student response based on a 5-point Likert scale. So this is the result from the 47 response. The highest percentage, 9.9% of respondents strongly agreed with the survey statements, followed by 4.23% agree. Lower percentage were recorded for intermediate, disagree, and strongly disagree response, with some categories showing minimal or zero representation. So the average percentage distribution indicates an overall positive trend in student feedback. So the Likert scale used for evaluation range from 1 to 5, providing a clear measure of student perception. Additionally, the survey assess CLO, including CLO1, 2, and CLO3, to evaluate how well students believe the course met objective. So the findings suggest area of strength and opportunities for further improvement in the course design and delivery. In summary, the data highlights a generally favorable response from students with notable agreement on key aspects of the course, while also identifying specific areas that may require attention. As a conclusion, so the implementation of OBE in plant control system course has effectively achieved its intended learning outcomes, as demonstrated by strong student performance data, core course outcome review reports, and positive exit survey feedback. So continuous quality improvements initiatives, including AI-driven projects and tutorial handbooks, have significantly enhanced student engagement and understanding. So to further strengthen the course, future effort will focus on incorporating more real industry case study and interactive simulations, ensuring a seamless connection between theory and practical application. So this course remains a dynamic, industry relevant, and student-centered program, equipping graduates with the essential knowledge and skills for success in the field. So thank you for your time and attention today. So it has been a pleasure sharing the outcomes and the future vision for the DGL 553 Plant Control System course. So we welcome any question or insight you may have. Let's continue working together to advance excellence in engineering education. Have a good day. Thank you.